A population of soft drink cans has amounts of liquid following a normal distribution with a mean of 12 and a standard deviation of 0.2 ounces. We want to know, first of all, what is the probability that a single can is between 11.9 and 12.1 ounces? Now, this is exactly the sort of exercise we did in our last section. But question 2 is different. What is the probability that X bar, that the sample mean, is between 11.9 and 12.1 for n equals 16 cans? Now we can distinguish between these two because this one is a single can, and in number 2 we have a sample size. So we're going to see that we have to do the single can differently from anything that is an actual sample involved. We have to use the sampling distribution for the thing that has a sample involved. Okay, so let's do numbers 1 and 2. All right, so I said number 1 was like what we did in the last section. So let's do our z-score for both 11.9 and 12.1. So we'll do the 11.9 first. So we'll have that Z is 11.9 minus our mean, which is 12, over standard deviation of 0.2. So this gives us negative 0.1 over 0.2, or negative 0.5. Now we'll look that up on our table in a minute, but let's go ahead and do the 12.1 first, and we can just look them both up. So we've got 12.1 minus our mean of 12 over 0.2, which gives us a positive 0.1 over 0.2, or a positive 0.5. Okay, so let's look up negative 0.5 and positive 0.5, and recall for a between type problem, we look them up and we subtract the two probabilities, highest minus lowest value. So I'll look up 0.5 first because that's going to be the bigger one. All right, so I've made a little easier table here. So let's go to negative 0.5 and positive 0.5. So positive 0.5, if we look over here, is 0.6915. All right, so I'm going to write that down, 0.6915. And then negative 0.5, let's go back. Negative 0.5 is right down here at the bottom. Let me move it so we can fully see it. Is 0.3085. And if we do that subtraction, that probability is 0.383. Now, let's notice number 2 is a between problem, but we're looking at X bar instead of just an X, a single can. We have that a sample size of 16 cans. So we saw in the last video that for the sampling distribution, the mean of the sampling distribution is still the same as the mean of the population, but the standard deviation is different. The standard deviation of our sampling distribution is going to be the 0.2 that we have, this sigma, over the square root of n, our sample size. So for us, that's 0.2 over the square root of 16. All right, so if I do that calculation in my calculator, I get 0.05, and that's the standard deviation I'm going to use in this second problem. All right, so we're still going to do a z-score, and we're going to do it with 11.9 and 12.1, just like we did in number 1, but my standard deviation on the bottom is going to be 0.05. right, so this will be negative 0.1 over 0.05, and that's going to end up being negative 2. And then let's do the 12.1, and then we'll look them both up. This is going to give us 0.1 over 0.05, or positive 2. So we're going to look up negative 2 and positive 2 on our standard normal table. All right, so give myself some more room and let's go back to the table. We'll go to the 2 first because that will be the bigger number. 2 is going to give us 0.9773. And then we'll subtract off what we get for negative 2. Negative 2 is going to give us 0.0227. And when we put that into our calculator, we get 0.9546. And notice that's quite different than what we got right here, number 1. So if we have a sample, we have to use this for our standard deviation of the sampling distribution. If we have a single value, we are using the same information we used in our last section.